Okay, we are now on section 5.2. Systems of linear equations in 3 variables. Okay, example 1 says, show that the ordered triple -1, -4, 5 is a solution of the system. Okay? Now, guys, one thing I need to point out here, it's listed in alphabetical order, just like it is with an XY ordered pair. This is X, Y, Z. There is a Z plane, just like there's an X and Y plane. And you will, if you take other math classes, you will learn to graph, and it graphs 3-dimensional versus 2-dimensional is what it is, okay? We don't do that in this class. We have X minus 2Y plus 3Z equals 22. We have 2X minus 3Y minus Z equals 5. We have 3X plus Y minus 5Z equals -32. Okay, this one, all it wants us to do is to show that that ordered pair, -1, -4, 5, is a solution to that system. In order to do that, we've got to plug those 3 numbers in for X, Y, Z into all 3 equations, and all 3 equations have to prove to be true. Okay, that's what we got to do. So, I've got X minus 2Y plus 3Z equals 22. I'm going to put it in the first one. So that's going to give me -1 minus 2 times -4 plus 3 times 5 equals 22. That gives me -1 plus 8 plus 15 equals 22. Okay, that's going to wind up giving me, what, 7 plus 15 equals 22, and it is true that 22 equals 22. So there's one check. All right, let's check the next one. 2X minus 3Y minus Z equals 5. I'm going to plug in the -1, -4, and 5. That's going to give me 2 times -1 minus 3 times -4 minus 5 equals 5. That gives me -2 plus 12 minus 5 equals 5. That gives me 10 minus 5 equals 5. And sure enough, 5 equals 5. Okay, then for my last one, I have 3X plus Y minus 5Z equals -32. Let's plug in our -1, -4, and 5. That's 3 times -1 plus -4 minus 5 times 5 equals -32. That's going to give me -3 minus 4 minus 25 equals -32. That's -7 minus 25 should equal -32. And -32 equals -32. Check. So you're good to go. It worked in all 3 of them, so it is an order. It is a solution. So -1, -4, 5 is a solution. And your calculations down there prove that. Okay. Example 2. It just says solve the system. Okay. This time we've got x plus 4y minus z equals 20. 3x plus 2y plus z equals 8. And 2x minus 3y plus 2z equals negative 16. Okay, so it gets a little more intricate because now we've got 3 things we got to get rid of. And before, we had 2 things that we needed to get rid of. So what we did was we figured out how to get rid of one thing, then we could solve for one, plug it back in, and get the other one. Well, here's what we have to do this time. You've got to get it down to, you got to get 2 equations down to the same 2 variables. Then use your old techniques that you did in 5-1 and get that down to 1, okay? Now, for me, it looks like right here, here's who do I see that could go away? That I could just easy make go away? Z. Okay, so in my head, I need to get 2 equations that just have x and y in them. I'm going to get rid of that z because those z's have opposite signs right there, right? The first 2 have opposite z's. I got a negative z, got a positive z. I can add those and use addition method, and I can get it down to an x and a y. And then I just got to pair together 2 other ones and get rid of a z, okay? So I'm choosing to eliminate z, so I'm gonna make myself a little note. Eliminating z and producing 2 equations with just x and y. Okay, so I'm gonna take the first one, x plus 4y minus z equals 20, and 3x plus 2y plus z equals 8. That one's easy. Don't have to do anything to him, okay? So I'm going to get rid of those z's, and that's going to give me 4x plus 6y equals 28. Okay, now I've used, and I'm going to highlight him in green, I've used these 2 to make an xy. Now, I've got to pick, I got to go back up to the top, and I got to pick 2 more that I can get rid of z again and make another xy. Who you want to use? I would pick 1 and 3. Here's why I would pick 1 and 3. Because one's already negative. What do I need to multiply 1 by to get z to go away? 2. Okay, so I'm going to use x plus 4y minus z equals 20. And I'm going to use 2x minus 3y plus 2z equals negative 16. Okay, now I'm going to write what he's going to become over here to the right. Because here's what I'm going to do with this one. Okay, we have, y'all are getting that look at me. We're using 1 and I'm using 3, right? Okay, so I'm going to multiply. Y'all tell me multiply that top one times 2, right? And here's that over there. That's 2x plus 8y minus 2z equals 40. And 2x minus 3y plus 2z equals negative 16. Okay, so I used 1 and 2, then I used 1 and 3. 1 and 3. All right? So that gives me 4x plus 5y equals, those z's go away. That's nice. Let me make sure I multiplied that right. Yes, equals what, 24? We like 24? Okay. Now, good job. You've got it to two equations that have two variables. Okay, we can work with that. That's what you've been doing. So I'm going to take those two, 4x plus 6y equals 28, and 4x plus 5y equals 24, and I'm going to get rid of something. Who's the easiest thing to get rid of there? The 4s, those x's, right? I personally am going to multiply the second one times the -1 because that 5 is smaller than a 6 and that 24 is smaller than 28. So when I add them together, I get positive numbers. I try to make myself look better, guys. And if I can get positive numbers, I look better in the end, okay? So this becomes, 4x plus 6y equals 28. And that's negative 4x minus 5y equals negative 24. Y'all know that's the hardest part of teaching, right? It's trying to get you to see it how I see it in my head. The math's not hard. It's getting another human to see what I see so they can get the right answer. And so we have to lay a path to get you there. And sometimes making that path a little bit hard. When I first started teaching, I would literally go, you see what I'm saying? Okay, good. And then that's for kids. That's for kids the first year. I mean, I was 21 and some of them were 18. And in Algebra 1 for the third time of their lives. Yeah. They didn't see. And I wasn't drawing a good path. Let me tell you. Poor things. They're like 44 now. Anyway, okay. So I moved over here. I multiplied that second one times -1. Those 4's go away, right? And look at there, 6y minus 5y. Oh, that's so nice. I get y equals 4. Ooh, that's great. That's great. Okay? Now, what would we normally do with him? If we just had two systems, we would what? Put him back in one of those originals, right? Those two variable ones. So that's what I'm going to do. I'm going to put him back in, let's put him in, let's just put him in the first one. It doesn't matter. I like the first one. So I'm going to say 4x plus 6y equals 28. Okay, so that's going to give me 4x plus 6 times 4 equals 28. So I get 4x plus 24 equals 28. I get 4x equals 4, right, when I subtract the 24 over. And then that gives me x equals 1. Woohoo! I got 2 of the 3 of them. Now, how am I going to get OZ? You got to take your x and your y. It's like we're going backwards, and I got to take one of those true original ones and put an x in him, a y in him, and get that z back. I'm going to pick the second one. Why am I picking the second one? Because he's already just plus z. He's going to work out great. I don't have to divide. I don't have to change a sign. It's going to be much better. Okay, so I'm going to take x equals 1 and y equals 4, and I'm going to put it back into 3x plus 2y plus z equals 8. So that gives me 3 times 1 plus 2 times 4 plus z equals 8. That gives me 3 plus 8 plus z equals 8. That gives me 11 plus z equals 8. That gives me z equals -3. Okay, now write them in the correct order, x, y, z. So I'm getting the 0.1, 4, -3. Let me see if we can actually put that. I don't know if the standard Desmos graphing calculator will take that. Since it graphs in 2 dimensions. There is a 3-dimension, like if you use GeoGebra, GeoGebra will graph in 3 dimensions for you and put that z-axis in there. Let's see if Desmos will let me do anything like that. I'm not sure that it will. X plus 4y minus, see, I don't even have a z, yep, equals, no, I don't want my slider, equals 20. Yeah, he's not wanting to do that because he's wanting to change. We could put in, what did we say z was going to be? What was my answer for z? -3. Okay, so let's say this is, if I put in -3 there, I'm just checking. You guys don't have to actually do this. Where am I at? -3 we said, so that was going to be +3. Okay, and then I've got 3x plus 2y. We said -3 minus 3 equals 8. Y'all make sure it fills my fingertips. 2x minus 3y minus 6, because -3 times 2 is -6, equals -16. And let's see where they intersect. Okay, so we're saying that z is -3, and when I touch this little button, that means x and y need to be 1, 4. Okay, the intersection of all 3 of those lines needs to be 1, 4. And I get 1, 4. So we are correct. That's with setting z equal to -3. Okay, we could probably do the same thing. You would have to switch. You don't want to do that. You don't want to do that. That's okay. Let me see if there is, let me look. Add, let's say 3D graphing calculator. Oh, there's a 3D graphing Desmos calculator. Yep, there he is. See your Z? Okay, so we can check it out. Y'all are like, can we just move on to that? Look here, guys. This is cool. Okay, then we have, of course, I'm not sure we can see real good where they intersect. Uh-oh, he didn't get my 2, did he? 2y plus z equals 8. And then, ooh, you're not going to be able to see that good. It's too muddled. Lord, I can't see. Can you see? Oh, my. Okay, come on. Where are you going to hack each other? I can't see. Because they they should enter, okay, right there. It won't let me, oh my, it won't let me get in there. Okay, we don't, okay, that's going to make us dizzy. Okay, yeah, well, we know we got it right. Oh, it's still twirling. Okay, we're good. All right, let's look at example 3. I'm sorry if I caused a migraine to onset there. Example 3 is our last one. I do think GeoGebra graphs it better. I'll look up the free GeoGebra graphing interface. I will post that on your homepage on the module, like I have the TI-30XS, so that way you can check course, your homework will come back and tell you you're wrong real fast, won't it? Yeah, you'll go, nope, wrong. Well, hopefully it'll tell you which one's wrong, because you could have one of the three right and just messed up after you substituted things back in. But anyway, solve the system. We have 2y minus z equals 7. We have x plus 2y plus z equals 17. And we have 2x minus 3y plus 2z equals negative 1. Okay? Now, guys, all this is that first one, he doesn't have what? An x coordinate. So his coefficient in front of x is 0. We're still going to work through this pretty much the same way as we did the last one. Who do you think I would like to get rid of? Z. I'm going to get rid of z. I'm going to turn this into an xy, and then I'll do another xy. So I'm going to use the, for me, I'm going to put the first and the second together because they're a -1 and a +1. They can easily be eliminated. First and second, I'll even label it that way. So when you go back and look, you're not going, what were we even doing here? Because when we solve systems, sometimes we enter the land of what is going on. It's kind of like if we were wandering around in a desert and we're trying to figure out to get back where we want to be. Okay, so the z's are going to go away, and that's going to leave me with x plus 4y equals 14. Okay, now that's putting first and second together, and I've got an xy left. Who do you think I would like to put together next? I'm going to put first and third because they're opposite signs and get rid of the z. Okay, so I have 2y minus z equals 7, and then I have 2x minus 3y plus 2z equals -1. I'm going to multiply that first one times 2. That's going to give me 4y minus 2z equals 14, and I have 2x minus 3y plus 2z equals -1. Okay, those z's, yep, they're gone. That leaves me with 2x plus y equals 13. Y'all okay with that? I did make some space there. I probably should scoot him up. Okay. Okay. Now we're going to use those two, not that button. We're going to use those two. My x plus 4y equals 14, and my 2x plus y equals 13. Who would you guys like to eliminate? Y'all want to eliminate x, or you want to eliminate y? Or we could use substitution and move 2x over and substitute in y. We'll do that real quick, okay? So we'll use substitution. So I'm going to turn him into y equals -2x plus 13. And I'm going to put him into x plus 4y equals 14. So everywhere I see a y, I'm going to put in -2x plus 13. So that gives me x plus 4 times -2x plus 13 equals 14. Okay, that's going to give me x minus 8x plus 52 equals 14. That's going to give me -7x plus 52 equals 14. Subtract that 52. That's going to give me -7x equals, what is that going to be? Will it be negative? Is that not nice? Is it, so 12 minus 4 is 8, right? And 38? No. Yes. Yes. Ooh, that's ugly. Is that right? Is it negative 38? Somebody tell me. Oh my goodness. Y'all are going to make me on recording go over here and question myself. Okay. Divide by negative 7. I don't like that we have that fraction. And I get x equals 38 over 7. That is not friendly. Okay, I'm going to plug that back into the first one, guys, okay? To get my x, so I've got x plus 4 times 38 over 7 is supposed to equal 14. Yuck. X plus, we're late. 4 times 3 is 38 times 4. 8 times 4 is 32. Carried 3 is 12, 13, 14, 15. 152 over 7 equals 14. X is going to equal 14 minus 152 over 7. 14 minus 152 over 7. That looks atrocious, guys. Negative 54 over 7. Oh, I already got an X. What did I do? I plugged him in the wrong one because I got disturbed. Okay, do you see what I did wrong? I plugged in X for Y, didn't I? Oh, guys, okay, nix that. All right. Let me fix that on camera here so before you go so it doesn't look like I just went, oh, God, I don't know how to do it. I do. That's going to be, I'm going to put it into, if you need to go, go, because I know we're over time right now. That's going to give me 38 over 7 plus 4y equals 14. So that's going to give me 4y equals 14 minus 38 over 7. If I go over here and say 14, I'm going to go back over here. I say 14 minus, delete, 38. Was it 38 over 7? Okay. 60 over 7. That's not much better. 4y equals 60 over 7. Actually, that is better. That's going to wind up giving me y equals 15 over 7. When I divide by that 4 will go into 60 15 times. So that's 15 over 7. Then, guys, you need to go back. I would plug it in the first one because you've got y. There's no x to plug in. That'll give you z. So that was what? 2y minus z equals 7. So 2 times 15 over 7 minus z equals 7. That's 30 over 7. Minus z equals 7. That's really going to be 30 over 7 minus 7 equals z. If I go over here, that's really 30 minus, 49? So negative 19 over 7 equals z. Woo. So I'm getting 38 over 7, 15 over 7, with negative 19 over 7. And I will check that. If it is not correct, I will type in the description in the video. Example 3 should be this at minute so-and-so, and I'll post a revised, I'll say revised example 3, okay?